see what we got here. As we start, I don't figure too many people hanging out watching this I'm working on. In fact, I'm gonna go get one of the folders for one of the things I've been working on. I'll show you guys in just a little bit. All right, hey guys, I see there's a few people starting to show up. Hope everybody's doing all right. We'll be talking a little bit more about some stuff today here in just a few seconds. I just want to go grab this folder. I printed out some stuff I'm going to show you guys. All right, back in business. Okay, we got some guys watching. All right, so here, I figured, so it's Sunday, and I had some projects I needed to work on here in the shop, and I thought I would just talk to you guys. I thought I'd share some of the projects I'm working on. Some of it's for fun, and some of it's for business, and I'll share a little bit of both with you guys today. I like these live videos because they let us interact a lot more than me just shooting fully edited content. It's not as structured, so it's not as concise, but it definitely gives us a little bit more back and forth, which I like. So I'm going to snag my iPad real quick while this machine boots up. Talk about some of these machines. Okay. So I've got my iPad so that we can, so I can read some comments and stuff. So I don't have a computer in front of me. Man, the last year has been, it's been like playing musical machines. At least that's what it feels like. You got all these little pieces right here because this represents like an end mill, and this represents like a piece of material. So I got a bunch of this stuff right here. In fact, I'll leave it on this folder for now. What we're going to do, I have a video that I'm shot with an overhead camera rig where we're going to talk about chip thinning. As I was shooting this video, I started looking for aids, for teaching aids, and I found this awesome little sheet from Macintosh Tool. So if you type into a search engine something like chip thinning chart or tool, I think I actually typed in tool engagement angle. There's an awesome little diagram here, and we're going to talk about that. And I thought it was a great topic to discuss because we have a couple of different machines here. We have our VM2. We have a new Okuma M560, which we'll talk about here in a minute. And then we have the X7. And what's crazy is that, I shouldn't say it's crazy. What's interesting is that each of these machines kind of have like this sweet spot for cutting tools and feeds and speeds. And the more you kind of learn the machines and the tools, and you don't have to have like some super deep understanding of physics, but understanding, that tools with higher flute counts have more flutes in the cut can, it creates more tool pressure. So you're going to have more chatter, if the machine's not rigid. So let me fire this up real quick. You guys have never owned a Haas machine. They're pretty straightforward. I fired up the compressor right before I got here. And all you do, it tells you what to do right here on the screen. It just says open the door, turn the emergency stop to release it, and then press power up. So just recycle the door, gives you a green check mark. You release the e-stop. I see a lot of guys, some guys hit reset. It tells you to hit power up, so you hit power up, and then the machine homes out, and that's it. It's warmed up. The spindle on this machine is actually incredibly quiet, which you guys are about to see because I'm going to warm the machine up while we're making this video because I actually have stuff to cut today. And I'm going to bring you guys over close today, which is something that I don't see a lot of people do. And I'm going to show you a little bit of, I guess, what I would consider some of my own tradecraft. And so I pull the spindle out every night. If you guys ever wonder why my machines are super clean, I know my mom doesn't like when I say that we grew up poor, but that's what she used to tell me. But I grew up quite modestly, so I'm like incredibly particular about the things that I own. So anyways, I always take the tool out of the spindle before the end of the night, and I put the tool back in. So that's what we're going to do. Another thing, I'm not going to drag the camera over here and show you guys, but I always take a little file and or like a razor knife, and I put a little X on the drive dog so that when the spindle is oriented, I know what the front drive dog is. That way I always reinstall my tools exactly the same way. Oh, I guess I got to hit cancel. MDI. So the other thing that I always do is in MDI, I set the center of the machine travels to G59. That way the table is always dead center. I can always command the machine to a dead center travel. That way things aren't kind of sitting quirky. Again, there's probably no real need for this. I'm just a little obsessive. But G59, G00, X0, Y0. By the way, that's as fast. That is as fast as the VM2 goes. That was full pull. And then list program. I'm going to choose spindle warmup, select program, memory. You can hit go, but Haas tells you on a 15K spindle to turn up the spindle speed. So 1, 2, 3, 4, 5, and now go. And now it's going to warm up. And you'll see that the spindle is actually quite quiet. I'm actually pretty happy with this machine. The only gripe I have at all with this machine, well, okay, there's two gripes, I guess. I wish they used like a stainless way cover, like a higher end way cover, because the way covers are kind of getting this blackish, I don't know what it is, chemical reaction on them. Doesn't affect performance as far as I'm aware. And the spindle has a little bit, I didn't realize that Haas has a spindle spec. The runout for a brand new spindle is about 1/1000th of an inch at 6 inches, which I thought is kind of high, but it is what it is. I talked to some different companies, and if I really wanted to get super crazy with it, by the way, if you're using like 1/2 inch end mills, this doesn't matter. But I use a lot of really small end mills, like 1 millimeter end mills. Like, show you guys two of these. I have one application where I got to reach way, way down. In fact, I want to bring this over and show you guys. So this is a little 1.5 millimeter end mill that probably won't focus. And then I have one that needs to reach way, way, way down. Okay. And so when you're trying on a tool like this, you know, this is 7.5 or 8 inches. When you've got 1/1000th of an inch of run out here, the chip load on this tool right here is 2/10,000ths. So if you guys are familiar, that means that every time the cutter introduces a flute into the cut, the machine commands forward motion or vectored motion 2/10,000ths of an inch. So if you have 1/1000th of run out, you're going to break the tool, blow the tool out, prematurely wear the tool. And so you want the very least amount of run out you can possibly get. But on this tool, just for the record, if this tool has less than 1/10,000th of run out, I actually tapped it in with the good old fashioned hammer and screwdriver method, and it actually lasts quite a long time, but it's just a pain in the butt to have to do that over and over and over. And on your shrink fit tools, like the one that are in the machine, there's not really much you can do about it. Let's see here. Okay, so here's what I wanted to talk about. We're a tool and die shop. We don't do production. We don't. Very, very, very rarely do we like make buckets of chips. In fact, if you guys can, I know you can barely see that blue bucket that's underneath the chip conveyor. We do like one of those a season, like very little. What we do is small amounts of material removal, but accuracy, features, like little features, things like this. This is what we do. But I'm now getting into doing more of our plastic products in-house. We have a new small plastic injection molding machine, and we kind of bought it to make a couple of small products, and we're experimenting with some other products with it. We don't really know how it's going to work out, but that's just the way it goes. When you're not a pro, when you haven't been you haven't been involved in an industry for a decade, or you haven't ran through an apprenticeship, sometimes you got to learn. And sometimes I feel like buying a lower entry level piece of technology is a great thing. The same skills that you learn on the little Syil X5 or X7, those same skills transfer to all of these other machines. Understanding the work offsets, the tool offsets, things like this. So let's talk real briefly about machine decisions. So we bought this because we really needed true 5-axis tool paths for some small cores that we make. And we have all kinds of stuff that we develop that the world never sees. A lot of stuff, as a matter of fact. In fact, there's a lot of stuff that nobody but this people in this building, because we make it, we test it, and if it doesn't, like, if it isn't substantially better than the products we currently make, we don't release it. It's just that simple. I don't want to release something that is like just incrementally better. It's got to be substantially better. But having the ability to iterate on a machine like this is just, it's so valuable to have. However, I was surprised to find out that our little X7 that you guys have seen so much of lately, how accurate it was, how good it's worked. A lot of our smaller stuff has worked amazingly well. And so this is the size of one of our current injection molds. You see it's pretty small. It's a pretty small mold. Here's the activator pins. I think there's a good chance we're going to make most of those. And here's one of the slides. I think there's a good chance that we're going to make most of our injection mold parts on the X7 because it just fits so cleanly in the work envelope. The only thing that would encourage me to make some of the injection mold parts on this machine or the Akuma are just the fact that they have more kind of robust probing systems installed on them, which we're going to talk about here in a minute. So I had got this. The original plan was to get a VF2 of some sort as kind of a sister machine. So we ended up getting this machine, and then we ordered it. And we ordered it for 2 reasons. One, I'm not going to lie to you guys, I'm a little nervous about inflation. And sometimes I think having the stuff is more valuable than having the money. And so I liked the idea of having some redundancy. There was a time when I was told by our HFO that service techs could be 4 to 6 weeks out, depending on how busy everything was. Even right now, I think if you call Haas right now, I think they're still like them. Well, let me just tell you this. We ordered our VF2 that was supposed to be the sister machine to this on October 25th. The original proposal said 9 to 11 weeks, and then the sales order said 9 to 13 weeks. On October 25th was the October 25th or 26th-ish was the date that we signed the order. In early February, it was supposed to be February 10th. And then on mid-February or early February, they called me and said, hey, look, it's going to be March 19th. And so clearly there's a run on Haas machines. People are buying Haas machines for whatever reason, which is, it's a good thing. But when we saw that type of delay, 2 things happened. The delay hurt us because we had some other projects that we're working on. And then the spindle runout thing kind of was a concern for me. I love these machines. I think they're great machines. I would buy this machine over right now. This is basically a VM2 that has every option you can get. One thing that someone warned me about, they said, hey, the table with all the slots, it's really convenient for work holding and fixturing, but it's not always as flat as like a traditional just 3-slot table. And I would agree with that. I actually have some video where I kind of jog around with an indicator within like the trucks, within the guides, the linear guides, the rails, linear guides, and it's flat within, I don't know, a few 10,000s, maybe 3 or 4 10,000s, two or three 10,000s. But when you get outside of the trucks, there's just some movement. But all in all, it's good. Knowing that we're going to be doing much more plastic work, I know we're going to need a surface grinder. It's inevitable. It's going to happen. But that's why I really decided to get this. These machines are incredibly, they're just nice machines. In fact, let me go ahead and come around here and show you this side. This machine hasn't actually been commissioned yet. You guys can see it here. I'll just tell you a little bit more. So you can see in here that this is a machine that has, over 40 inches in X. I want to say 41 inches in X, 22 inches in Y. Just super nice, incredibly rigid, incredibly accurate. People have asked me for over the last few years, what do I think the best VMC is for the money? And I think that hands down, if you're in the arena of buying a vertical machining center in that, let's just say $100,000 range, I just think this is the best one. Period. End of story. For a billion reasons. And I don't have any, relationship with Akuma other than, I bought this machine from Gossiger. I just think that it's rigid, it's accurate. It's got a dual contact spindle. It's got a 32 tool changer. Something that's a little bit different with these machines. Let me see if I can turn this around so you guys can see a little bit more inside there. Something that's a little bit different from these Akuma machines compared to the Haas machines is that when you buy the Akuma machine, you actually have to invest in all those oils that you see right there. You have to buy that stuff. That doesn't, when they come to commission the machine, they expect you to have a couple of buckets. Now, I overbought. I'm not gonna lie to you guys. You don't always need 5 gallons of everything. Some of these are like a gallon or 2 gallons or whatever. And then you have to buy this grease tube to grease the machine. And you can see that's the transformer behind it. But that's why I ended up purchasing this machine. I just think that it's a fantastic machine. Show you guys a couple things. I'm going to show you guys a couple things that about these three. And there's the X7. We're actually waiting to power it back up with a new circuit. You can see there's a Vise sitting on a chair there, or on a stool there. And the reason that Vise is down there is because I just got done shooting content talking about the perfect Vise for this machine. And in my opinion, there are 2 Vises that are awesome. I'm going to grab the other one right now. I'm just going to set it right on top of that Vise. So that Vise right here is the Tagara 660U, and you can see that it's been machined on the sides. It's machined so you can tip this thing up on its side. This is the, which I've already covered all this in another video, so I guess this is a little redundant, but for you, those of you that are hanging out, you can move this really quickly. It's kind of like a chick workholding Vise. It's made by M-Lock, M-Lock. It comes back and forth, and then when you lock this one down, this one just clamps it real quickly. So it's really narrow profile. So these 2 Vises, far and away, are my first choice for the X7. If any of you guys do have one of these or thinking about one of these machines, if you want a traditional 6-inch Vise that you can use all the traditional 6-inch Vise jaws and stuff like that, I'm a huge fan of this Tagara 660U. I have seen guys squeeze in bigger Vises like the DX6 or the larger Tagara. Mine, when I would close the door, there's a light in here. There's a light in here that I've got. I don't have it plugged in. But when I would close the door like this far lip would run into the handle on my larger Vises. So it was either cut that down or buy this. And I thought this was just a better solution. So I really like this Vise, really like this. But this machine has been incredibly accurate. And it's just been it's honestly been really nice. The only thing I think we don't have worked out just yet is they're updating some of the screen sets. I got an email here this week that some of the screen sets have been updated, and the integration for the probing system to finally get all the macros working in a more user-friendly setup is coming. It already works. The macros for the probe do work, but they're making it so that it's more user-friendly. So we'll see how that plays out here in the next couple of weeks. I'm going to come over here. Oh yeah, here's what I wanted to show you. Here's a little tip if you guys end up programming. On this machine, I wish there was a little bit slower rapid, because this machine is bullet fast. 1,100 inches a minute, and a machine this small is like incredibly fast. So I wish that it had like a 5% or a 1%. You didn't hear this from me, but the parameters are available in the control. So you could hypothetically turn it down from 30,000 millimeters a minute to something lower. And then those would be percentages. This would be percentages of the new value. But I'm not into changing parameters. Here's the spindle speed. So 100% up to 120. And here's the feed rate. The one thing that I have to admit to you guys, I use a lot of high feed end mills. And traditionally, I've always programmed my machines very conservatively, because on the Haas machines, you can turn the spindle speed or the feed rate up as high as you could ever want. You can override it as far as you want. But on these machines, if this is 1,000 per tooth, 0.02 millimeters, then this is 1.5 thousandths per tooth. You can't like double it or triple it. So you got to be close. In fact, sometimes what I like to do is I over program my feed rate. Like I'll choose 5 thousandths per tooth and I'll just run it back, especially if I'm experimenting with new tools. Now I've kind of got it figured out, but same thing with your spindle speed. You can always turn it down, but you don't have a lot of room to go up. But I do have to really love the knobs. I wasn't used to the knobs and like the kinematic controls, but I love it now. I love the MPG sim. You guys have already seen all that, so I won't bore you. But check this out. On this is something that I think is really, really cool. Just trying to get this camera zoomed. Check this out. You can turn the rapids down to 0.5%. So someone had asked me the other day about how to safely run a machine like this. And the same rules apply. You turn the rapids down to pretty much as low as you can, or as low as you're comfortable with. So in this case, we would turn it down to say maybe between 5.5%. You then turn on single block. And right here, sorry, I zoomed in a little farther than I realized. You turn on single block, and then you would just step it through. You'd step it through while you checked your position screens. It's really that simple. It's pretty straightforward. Let me show you guys about the Haas, last but not least. This is, I'm going to go ahead and argue that the Haas is the best. When I say best, I mean most user-friendly control available. And so I want you guys to see something. We're at 11,250, and the feed rate is at 100%. You can bump the feed rate right here, which doesn't matter because we're not feeding. But you can see that it keeps bumping, right? So not only can you just keep going forever, so just so you guys know, this Haas is running at full rip. This is 15K right now. It's nice and smooth. Touching the cabinet's nice and smooth. It sounds nice and smooth. So, like I said, the Spindle has a touch of runout, but the rest of it's great. But so here's the other trick you can do. So you guys just saw, You guys just saw me use the feed rate up and down like this. But you can also do this. You can also choose this button right here, handle feed, and then you can turn it up like this. I'm using. So let's see how high I'll let you turn it up. 999% is how much you could, or you could go back to 100. So let's see if I can get some back out to the standard distance. Oh, somebody had asked me about an EDM machine. This is our EDM machine right over there. We have a Mitsubishi EDM machine. All right, so now I'm going to sit down, you guys. I'm going to sit down. I'm going to grab the. I'm going to grab the. I'm going to check for questions and I'll answer as many of those as I can. And this thing will be done warming up in just a second here. So let's see. Oh yeah, this is the bottom side to an aluminum mold for a body for a radio controlled car. This is just the bottom side. It's going to go onto a fixture. And we're going to cut the top side. So there's going to be a video of that coming here. I'd imagine this is my project today. I got two projects. I'll explain more when this thing's done warming up. The two projects today are to build the rest of the fixturing for this tool right here and to use the probe in this machine to inspect a slide for an injection mold that was manufactured inaccurately. All right, let me see what we got here for questions. Okay, so what's my opinion on the new Haas TM series? Just bought the TM op, haven't received it yet. Matt, I think that I don't know too much about the tool room mills, but I do know that they have castings that go all the way to the floor, which I think is a good thing. We have shutdown programs that run at night that empty the tool in the pocket and put the centers on the table. Good call. And someone says that's why I explain why my machines are so clean, because we don't make that many chips. That's also true. What's the deal with the Akuma? I was happy to see your video a while ago, and then it disappeared. Without getting, I don't want to bore you guys. There's no crazy drama. I don't want to bore you guys with any of the stories, but let's just say that our circumstances changed, and this situation didn't work out. And as you can see, we still have a good relationship with Gossiker. I still love Kuma. You know what I mean? So let's see. Matthew, we run super small end mills and end up getting an air turbine. The runout is almost non-existent, and the spindle speeds are good. Yeah, I agree. We've looked into a couple of those. Typhoon makes one, the Iskar version, which is actually not made by Iskar, but it's called the Typhoon, which is super cool. That's the one that's TSC driven. If any of you guys are looking into these air turbine spindles, or these are 40, 50, 60,000 RPM spindles, they can be driven through spindle air. You can hear my compressors running. They can be driven through spindle coolant. Now, something to keep in mind is that the TSC system in this machine here. Oh, by the way, I know I'm getting old. I'm getting a little old and decrepit. You guys know I've had a couple back surgeries. I liked it. I liked that feature. I thought it was cool. So, but gallons per minute is a big deal if you're going to use a through spindle coolant driven spindle speeder. So I would be careful. From what I understand, this system here is the 1,000 psi system that I got from Haas, and it's about 3 gallons a minute ish. 3 gallons ish. So before you buy one of those spindle speeders, by the way, and the ones that use air can use quite a bit of air. So NSK actually makes a spindle speeder that is electric. So you grab it, put it in the tool pocket, and it gets plugged in, and it can run. I think they have them that go up to 80 or 90,000 RPMs. Let's hear. What vices are going in the Akuma? I'm not sure yet. Mostly fixturing is going in the Akuma. I've ordered some steel to build some new fixturing, and we're going to be making a lot of our mold cavities. And I have some other electrode fixturing that I've designed that I have to finish building. We're going to use our old stuff for now as I build the new fixturing, but that's mostly what's going to go in it. I'd really be curious, have any of you guys used the really powerful electromagnetic chucks? Because I'm leaning heavily towards an electromagnetic chuck for the Akuma. We have some of these bigger mold plates that are 17 inches square, 17 by 17 by about 3 inches thick. And it sure would be nice to be able to get to all 5 sides, the top and all 5 sides, without using either toe clamps or having to kind of do the toe clamp shuffle. You know what I mean? So if any of you guys have used any of those, if you guys can see, this is actually a This is actually an inexpensive, by inexpensive I mean $400 or $500, chuck that I've used to make the mold bases that are actually running right now for products that we have right now. And I used it in the X7 so that we could reach around pretty much all the sides. Right now I have this slide magneted down, and what we're going to do here in a little bit, I went into Fusion 360 and I created an inspection program that's going to inspect all of these features, because I have the drawings, but I know that when we run the part in the injection machine, it's not making good parts. There's flash issues, there's all kinds of issues, and one of the slides looks like the original mold maker welded it up and remachined it, and they did a pretty crappy job, to be honest with you. So I'm trying to decide, do I want to just grab the TIG torch out, tack a few spots onto this thing and fix it, or do I just want to inspect the entire thing with the VM2 and the Renishaw probe and just make my own, make a fresh one from start? So that's where my head is at right now. Someone says, Scott K says, just curious, since you're obviously using mold machines, what about Makino? I think Makinos are absolutely magnificent machines, but they also have magnificent price tags. And I guess if you guys, man, this could turn into a very long live stream. Well, so what makes these machines different? What makes a VM2 different from like this M560 or its little brother, the 460? Machines generally are rated in travels, right? The X travel is a very common way. So when I hear people talk about machines, I hear them talk about the spindle taper. Is it a 30 taper, 40 taper, 50 taper, or HSK? Then they talk about the travels. You know, is it a 40-inch machine? I always hear people say, is it a 40-inch machine? Meaning X travel, 40-inch machine. The other, so the taper, the spindle itself, you know, the horsepower in the taper, the travels of the machine, and last but not least, the construction of the machine. These machines are all basically C-frames, right? So you're looking at it like this, and the spindle kind of comes up and down, and then the bed, it's a bed slinger. It slings the bed X and Y and up and down, and that's that. On a small machine like this little VM2, just so you know, a VF2 is 30 by 16. A VF2 YT or VM2 is 30 by 20. By I think 24 inches, 20 inches in that for Z, maybe, I don't know. But these machines, for the most part, I think are pretty solid little machines. This is about 9,000 pounds, 8,800 pounds, maybe 9,000 pounds. The M560 is like 18,000 pounds. It's it's in a different class when it comes to rigidity. But when you're hanging this head, you know, I don't know what this is. In fact, I've got a tape measure. We'll check right now. See where I put my tape measure. So the center of the spindle on this machine here is 20 inches from the weight covers. So, you know, the weight covers probably stand off the column a couple inches, so 20 inches. But when you've got a machine that is 30 inches or 40 inches, one of these really big C-frame machines, you've got a huge amount of cantilevering that's occurring. And I mean, if that's not really accounted for in the design, it can create a lot of issues. When these machines heat up, I don't know if you guys are familiar with this, but the coolant runs through the head. If the head gets hot from the spindle running for a very long period of time, the head can actually grow. And so your parts can start to deviate mostly in Y. And so, and I know this because we make some electrodes. We made some copper electrodes that on another machine that isn't here anymore. And what would happen is when the head would grow, that Y travel, when we put it in the EDM machine, we would measure it in Z, and the Z was just all over the place. So we did everything we could to stabilize the temperature, but I would say that that's something to keep track of. So the Akumas are they're kind of like technically they're a C-frame, but really they're like a bridge mill. There's just so much mass. The table only moves in Y, and then the head moves in X and in Z. So the Makinos are similar. They're more like a bridge mill, at least the one I was looking at. I want to say it's called the F5. But just to give you guys an idea, you guys can go on Haas. This isn't a secret. I didn't get I'm not, I don't want you to think I'm griping, but I think I paid sticker, whatever sticker was. There was so much demand for the Haas machines when I bought this machine that I paid sticker. So if you guys want to go see what this machine it costs, this is a full pull VM2. You just go calculate it up. Go to haascnc.com. It's a full pull VM2 with every option you can get. See diagnostic. It's got every option you can get except for this one, custom rotaries. And I didn't add any memory, but I don't know. It was expensive, very expensive, and it's very capable. But this is the thing that I think if you guys take away anything from this video, take this away. It is incredibly difficult to find a 3-axis vertical machine that also does true 5-axis toolpaths. Any of the machines with FANUC OI controls are out of the question, which is almost everything except for Haas, Okuma, Herco, and I think Kitamura can do it. Those are the only 4. But all of the other machine brands that you look in, like Smart Machine Tools or Doosan's and things like this, I looked at all of those, but they couldn't do true full 5-axis toolpaths. And then on top of it, all of the rotaries that are out there in the market right now, they're these big bulky rotaries where the platter sits up really high and it kind of tilts over, where they basically run their rotaries as a B-axis with a that tilts, where Haas has this very unique design where it's kind of like low profile and you can run it as an A-axis. So, all right, let me get back to these questions here. Yeah, someone's mentioning the WTO cool speeds. We had already talked about the other ones, the Discard Typhoon and the NSK electric, and then the air turbine tools. Someone says, do we have an injection molding machine? Yeah, we actually mold a variety of products, both rubber and plastic here. Orange is coming out with the new Delta Vise. Orange Vises are super nice. I have a lot of the Pearson stuff. I don't know if you guys have noticed, but this is a Pearson Pro pallet system, and we actually have the Pearson Mini pallet system. So the way this works is that you pull this up. By the way, I don't know if you guys can see this, but there's air in the table. You guys probably can't see that. But the way this works is this comes up and it comes out. It's super nice, but you do have to pull the pallet with your part. And so I'm going to build some new fixturing where we're just going to bolt the parts in from the bottom, kind of like a Polk workbench. I'm going to build a heavy duty fixture riser so that we can just put the parts on, bolt them in from the bottom, and then that's how we're going to work on them. That way I only have to pull the parts in and out. I've had a couple of spine surgeries now, and even though I'm back to the gym and I'm getting healthy and trying to drink less Red Bull and more water, still pulling heavy stuff in and out of the mill a bunch of times a day is not easy. Let's see here what we got here. Someone says, when I cut graphite, do we use diamond tools? Sometimes, yes. I can tell you right now that these CVD tools, the chemical vapor deposition, these diamond tools can last. When you're cutting graphite to make electrodes, I couldn't really find, other than literature provided by tool manufacturers, there's no one that teaches this stuff. I guess maybe if you can find an apprentice program somewhere. But what I have found is that if you put just the right amount of stock to leave on the material, and then you use a diamond coated tool to finish it, like a 30 thousandths diamond ball nose. We've got them from a variety of companies. I like the ones from IDI myself, but they're expensive. They're like 72 or 74 bucks for one little 30 thousandths ball nose end mill. But they can last for huge amounts of time. It's incredibly impressive. But you got to leave just the right amount of stock. Makes a difference. Let me see here. Am I missing anything? TMs aren't castings, they're weldments. No, that's the opposite. From what I understand, the TM machine actually does have a casting that goes to the floor. It's the mini mills that actually have a weldment. And just for the record, the X7 down there, I've got a video of me moving it, which is going to be released here shortly because we moved it from this spot down to there. That thing has an epoxy granite casting that sits on the floor. And it's short enough to go in my garage. We were talking about this. My wife and I were talking like, man, is it worth moving the X7 into my garage at home just because I could kind of create a more sound safe studio. Like right now, when the rubber presses and plastic presses and the machine and compressors are running and everything's going in here. Uh, Not only that, but there's other businesses in this suite of units that we're in that are making noise. Sometimes I'll start to make a video and like the noise is so overwhelming that it just isn't possible. So we thought maybe moving the X7 back to my garage was a good idea. With the way these machines, was floor strength a consideration for your new current shop, or did you have to reinforce it? Yes, it was a consideration, but the owners of this building, when they had this thing built it with some pretty solid, with a solid foundation. Someone says, it looks like I also didn't opt for the full height chip conveyor. We didn't even get a chip conveyor for the Akuma because we just don't make that many chips. If I were making, I don't know, anything, if we were making supercharger housings or pistol frames or something, or we were making a lot of chips like Area 419 or some of these other companies, then you cannot get by without some method of chip evacuation, like automated chip evacuation. But we don't need it. We take parts that are the size of a softball and we make them smooth and shiny. Is basically what it comes down to. Someone said, are we still offering classes? I'm willing to, but that never played out. With the pandemic, the way that it kind of swept through the globe, and my wife and I just went on a short cruise. I was gone for the last 4 or 5 days. My wife and I went on a short cruise here on the West Coast, and I'm starting to think that, yeah, maybe it's time. Maybe it's time to do that. So let's see what we got here. Octane Workholding, which, by the way, I'm a big fan of Octane stuff. They got some cool stuff. Says that one of the biggest strengths is the lower end 5-axis Haas support, and that's true. That's 100% true. The ease of use, when you call a company like Gossiger because you want like an Akuma, or like say you call Ellison because you want a Doosan, they don't tend to look at the transactions the same way as like the Haas dealers do. The Haas dealers, it's kind of a I don't know. I mean, doesn't it say? I know Haas catches a lot of flack, and I think most of you watching this know that I've had my fair share of ups and downs. But the fact that you can go into MDI, type in F3, and now it says safe run, so that you're less likely to crash the machine while you're setting it up. The fact that on my phone right here, I'm going to get this out for you guys. This is called Haas Drop. And so it's basically like your own, is it necessary? No, but there's no question that Haas continues to push and innovate to bring new features and make their already user-friendly machine even more user-friendly. What they don't do is they're not trying to be a super high-end. They're not trying to be a Makino. Simple as that. And so you gotta. I think that if you're gonna buy a Haas machine, just know what it is. Just know what it is. That's all. Don't ask it to be something that it's not. And so I knew when we bought this machine what it was. I knew that there's a chance, just like when you go out and you buy a Chevy Camaro or a Ford Mustang or whatever, you could get one that's built flawlessly, or you could build one that's going to have some gremlins. It's the same way. It's the same way in a mass-produced machine tool. But I do love the fact that they let us do all the pricing online. You don't have to deal with pushy salesmen, leaning on you. So let's see here. GF Micron S500 weighs 6,300 kilograms, 10,000 pounds, within 10,000 pounds of M560. Hello from Norway. Can you possibly talk a little bit about why you chose an Akuma machine compared to other high-end machine brands out there? Thanks for the awesome streams and videos. Hey, man, thank you for the question. I appreciate it. I would say at the end of the day, I chose the Akuma. I guess if we're going to talk about the Akuma, let's point the camera at the Akuma. Let me do this. Here. How's that? I chose the Akuma for a variety of reasons. I'm about to get a little philosophical on you guys, so don't judge me. I've always felt like in life you need to read between the lines a little bit. And if you're at a bar and you ask a girl out on a date and you're like, hey, can I take you to a movie or, whatever your cheesiest line is. If she says like, you know, I have a boyfriend, maybe she does have a boyfriend, or maybe she just doesn't like you. Maybe she thinks you're too short, too chubby, you know what I mean? Not rich enough, whatever. But the answer is no. Okay. So if you read between the lines, no matter what this woman says to you, if you ask her out on a date and she doesn't say yes, the answer is no. I think when you read between the lines on these machine tool companies, there's something to be said. If you buy a UMC 500, which for the right, let me preempt this. Any of these machine tools in the shop, I love the X7. I love that little VM2. I love the idea of an M560. I haven't got a chance to run this one yet, but I'm hoping that it runs good, fingers crossed. When you buy a UMC 500, the 1-year warranty is like $9,000. There's a reason that price was selected, okay? When you buy this machine, it comes with, I want to say it's like a 5-year warranty on the control, 3 years on parts, and 1 year on labor. And for like an extra $4,000, or maybe $5,000 total, you can have a 5-year bumper to bumper warranty. And that says something. It says something about, it tells me that Akuma believes in the quality of their components. This machine, Akuma builds their own servos. I don't know if you guys know that. Most machine tool builders design a rig. They design like the frame and the casting and all this stuff. And then they go out and they buy things because nobody makes everything. No business makes everything. So they buy linear guides, and then they buy servos, and then they buy a spindle motor, like Yaskawa servo motors or Lincoln spindle motors, things like this. Well, one of the reasons I'll tell you, there's a variety of reasons I chose Akuma. I chose it because I believe in it. I think it's a quality product. The control is a little bit cumbersome, but it's also incredibly powerful, which I like the idea of being able to take advantage of that later on in the course of doing business and making parts. There's 40 million pulses per revolution in the absolute encoders, so the machine never needs to be homed. Just so you know, I want to say Makino has 67 million. So if somebody was talking about Makino, it's like now it's like the arms race to more encoder pulses. I don't know if that really matters. But I chose the Akuma because I think it's a good machine. I think if you go out and you look into the market, you'll see a lot of guys. Like say you go type into the search engine, VF2 problems or VF2 experience or Haas experience. You're going to get like mixed emotions. You're going to have some guys that have just absolutely love them because they're killing it and they're making tons of money on their stuff and they're just pounding out parts that are plus or minus a couple of thousands. And then you're going to get guys that either A, have a machine that maybe had some gremlins, or maybe their expectations were just inaccurate. And I can tell you that I am one of the guys that have struggled because almost nobody tells you how accurate your machine should be without cutting. I don't even know if Haas publishes accuracy specs anymore. There are different standards like VDI 3441, stuff like this. But on this machine, you can ask Akuma and they will provide you an accuracy chart. All of the things everything, the tram, the positional accuracy, the spindle runout, what is acceptable, and then what your machine actually gets. So I chose the machine because I just believe in it is the short answer. I think it's a quality machine. I think it's rigid, fast, accurate, capable. I think it's less likely to break down than some of the lower end brands. And we intend to do a lot of injection mold machining work on this machine. And I wanted something that was rigid and accurate. So I asked a guy once that ran a mold shop about machining molds because he had a couple of different machines. He actually had a Makino F5, but he also had like some Chevaliers. And we talked about Haas's and other brands. And he said, Jason, the biggest difference between a higher end brand or a really capable machine is that the better machines, you only have to take the cut once. Meaning, if you're going to surface something, let's just say you're going to do 10 hours of surfacing on a, I don't know, whatever, a mold for a hair dryer or a video game console or whatever, any plastic part you can think of. If you surface that thing and then you go run it through inspection and that surface is not in tolerance, you have to go back and run it again for another 10 hours. That's not cheap. So investing in a machine that's a little bit more rigid, a little bit more accurate, that doesn't deal with thermal deviation as much, I think can be worth the investment, especially if you're making molds. If you're drilling holes in tubing to make brackets and latches, then it never matters. It'll never matter. All right, let's see here. If I was starting out again, would I buy a brand new Syil or a used Haas? That's a fantastic question. Let me answer that real quick. Let me tell you what I think impresses me about both companies, and let me tell you what I think you should look out for. I think that the guys over at Syil are taking high quality components and they're building a machine with it. High quality servos, high quality linear guides, high quality spindle cartridges, just that kind of stuff. Where I think Haas is worried much less about the quality of the components of the machine. They're trying to create a very usable, profitable experience for their customer. Very easy to integrate things like this. I mean, the simple fact that the probing's all integrated, the macros, it's easy. It's just easy. So if you're experienced in machining, I think you can go either way and it doesn't matter. The one thing that concerns me about buying any machine tool is that these machine tools, all of them, every single one that's been in this machine, the EDM, the VM2, this machine, they're all breaking down sooner or later. Hopefully it's later, much, much later, but they're all breaking down. And so the nice thing about machine tools like this one is that I can call Gossiger and they can send a dude out with a van that can work on it. Whether it's under warranty or not under warranty, I can do that. And while I think the Syil is an amazing value, and I have made molds that collectively cost multiple of what it would cost to just buy the machine. So I've used the machine a fair bit. Like it's got a couple of 200-300 hours of machine time on it, I think. I got to check. But either way, we've made a bunch of molds, and the molds are in production, generating revenue. So I'm thankful for it. But if it were to break down, it would be something I would have to fix. And so that's something I think your skill set and your situation should dictate how you spend your money. If you're pretty skilled and you kind of have an idea of what you're doing, or at least you have a good understanding of what needs to happen, and you're ready to spin wrenches, which means if the machine crashes or you bang it up, you're willing to wrench on it, I think it sounds a great buy. If you're not comfortable with that and your livelihood is depending purely on this one machine, and if it goes down, it needs to be fixed, then I think you need to think about choosing a machine tool manufacturer that can come out there and rescue you if you make a big mistake. Because look, there's no ifs, ands, or buts about it. It's not an if you make a mistake. It is a when. We all make them. When I bought my first bike, I bought a 2004 Yamaha R1. It was the first year of the underseat exhaust. And one of my closest friends said to me, Jason, there's two types of riders: those who have been down and those who are going down. And there are two types of machinists: those who have crashed and those who will crash. It's just a matter of how hard, how bad, timing is everything. All right, let's see what else we got here. If you started out again, just so you know, if I started out again, I don't know, and I'll tell you why. The reason I bought my super mini mill when this whole shebang started was because I watched so many videos, like tip of the day videos. I mean, basically, Mark Terryberry carried me. I watched enough tip of the day videos, and there was one other college that showed high school or college kids running the control. Between those two series of videos, the control videos from the college and the Haas tip of the day videos from Terryberry, it gave me the courage to buy a vertical machining center when I had never touched one. And let me tell you something, it scared me to death. The first few weeks or months of owning that machine, I'd say the first month, I was scared to death. I was just so cautious. But once you can run that little machine, once you can run an X7, you can easily run this Akuma, no problem. All that's different is what you can do with it. The speeds and feeds, the material removal rates, the size of the parts. Haas, so there's a guy on here, you guys, if you're guys looking through the comments, there's a guy that I think it's worth reading his comment. His name's Andrew Dubuk. And Andrew's a good guy. I've talked to him on the phone a few different times, and he says Haas, and he's very knowledgeable, by the way. He says Haas were more economical in the past when you could repair everything yourself. They're now all locked down, much less accessible. Well, here's a tip. If you guys are going to buy a Haas, get yourself a service key. You can get a service key that when you plug it into the machine, certain parameters become available. In fact, maybe our next live video, if any of you guys are interested in this, in our next live video, if you want, I will put the service key in the machine and show you guys what parameters become available. There's 2 levels. I just have the basic level, the same one that any technician would generally have. Daniel says there's plenty of independent service techs that work on the style. That is true. Guys like CNC Repairman, this is true. Someone brought something up that's a very good point. There are independent guys out there that can work on the style. And by the way, all the parameters in the style are fully unlocked. So that is true. All right, well, let's see here. Craig says, my M460 spindle blew out randomly just before Christmas. Even though it's a year out of warranty, they just did the replacement as a warranty work. Well, that's pretty cool. I'm glad to hear it, man. I'm super glad to hear it. Someone says, did the first Akuma have a 5-axis trunnion, but now you've got a VM2 with a trunnion and a 3-axis Akuma? Yes, yes, and yes is the answer to that. Yes, yes, and yes. Okay, guys, I appreciate. Hey, just so you guys know, if you guys enjoy these videos, it would mean a lot to me if you guys would click the thumbs up button. All it does, well, number one, it shows me that you guys like hanging out here for a little while on a Sunday. And what it does is it tells YouTube that the next time I decide to fire up a live video, it's more likely to notify pretty much my subscribers, from what I understand. So if you like this video, please do me a favor and click the thumbs up button. I can see you guys doing it right now. It means a lot to me. I appreciate it. If you guys have any other questions why we are here, please feel free to ask now. And if not, I'm probably going to go ahead and grab my probing program and start probing that slide to see how close it is to the actual drawing. And I got a feeling that it's not very close. Dude, this, man, this is a tough one here. This question is the question you all need to be here for. It says, how do you compete with Chinese-made products? Whew. It's not easy. It's not easy. This is an education. Oh man, this is an education I wish I could have got a long time ago. So I think there's. I want to think about this before I shoot myself in the foot by saying this. I think there are 2 ways. There are 2 reasons you might buy a product. At least for me, I think there are 2 reasons people buy my products. They either buy them for you buy a product for its performance because it actually works good, like, or you buy it for style. And so let's just be honest. Does an Apple Watch, a Rolex and an Apple Watch, they both tell you the time. Maybe an Apple Watch is a terrible example. How about a Timex? A Timex and a Rolex. They both tell you the time. But you don't buy a Rolex because it tells you the time. You buy the Rolex because you want either the guy sitting next to you or the girl sitting next to you to know that you can swing the payment or that you have enough money to buy the Rolex. It's a status symbol. Simple as that. The other reason you might buy a product is for performance. And like, let's just say scuba gear. Would you buy cheap scuba gear? I wouldn't. I've never scuba dived. But if I was going scuba diving, I'd be buying the best scuba gear money can buy. And so the issue you have is that you need to know your market. You need to understand your market, which I didn't, and I feel like I have a better handle on it now. And you need to understand pricing. Man, it's tough to go here. It's tough to go here without getting into politics, but I'm going to do it anyways. All right. There's a funny little meme my buddy sent me. It's like some like college girl sitting on her Apple MacBook that says "crush" with a sticker that says "crush capitalism." Let me just tell you what capitalism is to me. Capitalism is you and me. We are actively voting each and every day with our money. When you go to a restaurant, if you don't like it, you don't go back. If you buy a product that is crap, you get your money back or you don't buy it again. And so the issue is, I feel like I compete with China personally by doing my very best to create a quality product that performs incredibly well and being very, very close in price to the Chinese products. And therein lies the rub. That's the hardest thing to do. I don't think it's hard to make products that are as good or even better. The the hard part is getting your operation efficient enough to be able to make money selling at a similar price. That's the biggest difference. And so like my competitors in my industry, they've kind of gone out and they've hired all of like they've spent a ton of money on all the pros. Like so they have a lot of like professional representation and they spend a lot of money kind of promoting this and promoting that. And so because they have such a incredibly much bigger margin on their products than I do. So what I've done is, I knew that I knew that if we either had to do it their way and compete in China, or if we wanted to come make our products in America, I had to find a way to compete. So what I did is I started building infrastructure. So they've invested in basically, let's just call it PR. They've invested a big part of their profits in PR to shape the culture and the perception of their brand. And what I've done is I've invested all the money that comes in from this business back into infrastructure. So I can't tell you if it's right or wrong. I think the only way you and I will know if I was right or if I were wrong is if I'm still here in 10 years. If we're still here in 10 years and we're still making products and I'm still passionate about manufacturing, then I made the right decision. If something happens and this becomes unsustainable or unmanageable, by the way, a variety of the machines in this shop to keep it running, to keep this business alive, are owned outright. I have now acquired them. The rubber presses, the plastic press, the vacuum equipment. I own all that. So I kind of feel like debt is a tool. You hear these old school guys say, oh, pay cash for everything. Well, I can respect that. And if you want a limited, a kind of incremental growth, then I think that's a great way to do it. But if you really want to have aggressive growth, then I think you have to leverage yourself a little bit. That's just my opinion. I would never encourage any of you to take a loan or do anything that you're not comfortable with. I personally would never consider taking out a loan for a CNC machine unless I had a product. I already had a product. I already had a contract. I already had some reliable source of ways to generate money with that machine. So I hope you guys know that. Last thing I want you guys doing is seeing all this crap in my shop and thinking that it's safe to just go take out loans. I don't want you to do that. I want you guys to make good decisions and succeed that way. Would I ever buy a Doosan? Sure, why not? Yeah, I would buy a Doosan. I think that they're good machines. I honestly think that we looked at a D&M 5700, we looked at a D&M 4500. Here's the issue. If you call Gossiger, this doesn't happen anymore, but if you call Gossiger, this machine here, I think, I don't know. I'm not gonna sell out my sales guy because I promised him I wouldn't. But I would imagine that this machine could be purchased anywhere in North America with the machine and a probe for in the $130-ish thousand range, plus or minus, whatever, who knows. And another interesting fact, the probes that come with the Haas machines are the OMP 40s, which is I think they call it a kinetic probe, where the probe that comes with this is an OMP 400, which has a similar mechanism, but also has strain gauges in it. So the accuracy of the probe that comes on the Haas is 1 micron. So just, that's like 60 millionths more accurate than the machine. But the probe that comes on this machine is plus or minus a quarter of a micron. Jeff Connolly is saying the problem competing with China is also they use machines like Akuma and Haas. Just I've been to China, I've been to Taiwan, and I've seen brothers and Makinos and stuff in China and Taiwan. There's no question, and their labor is much less expensive, which is why I've brought this up. Automation. There's no question. Automation is the final answer. Just so you guys know, automation is the final answer. If you really want to know how to compete with China, automate whatever it is you're making. That's all there is to it. That's all I can say. Elon Musk said it best. Building the machine that builds the machine is the hardest thing ever. But that is automation. Lewis, that's a great question. How do we get rid of that stuff? We're so small. We just take it to a recycling facility that's like 5 miles from here. We just put it in the back of my truck in buckets. In fact, right now, up at the front of the shop, there's like 4 or 5 or 6 5-gallon buckets full of old oil and coolant and stuff like that from different projects. And we just take it right up to the recycling facility. They take it right off the back of the truck, and we drive away, and that's that. Simple as that. And for the chips, there's a little recycling facility. We just put them right in bins. Engineered in California is not the same as made in California. I 100% agree. Just Daniel says Taiwan and China are 2 different things. 100% agree. I've been there. I've been to both. Taiwan is like a Western style government with Eastern culture. That's the way I feel about it. I really like Taiwan. I enjoyed being there. I felt welcome there. It's very interesting. It's very different. But China and Taiwan, I do notice that people seem to still kind of they lump them together. They lump Taiwan and China together. Not the same. Taiwan and China are not the same. Not even close to the same. Okay. All right. Well, we've been out here for a long time. So I appreciate you guys hanging out with me. I think we answered some questions. The one thing we didn't get to do was run these probing routines to start doing the inspection. But I'm working on, I've tinkered with dprint in the past. I don't know if you guys know what dprint is, but it's a service on the machine that allows you to probe surfaces, record numbers into variables, and then send them out. And I'm really looking forward to some high-level dprint integration. That's all I can tell you. And if I get it figured out, I'll share it with all you guys. But until then, that's that. So I appreciate you guys giving me the thumbs up. I appreciate you guys coming to hang out with me. I can't believe 65 of you guys or 64 of you guys decided to hang out with me on a Sunday, but it means a lot to me. Please stay tuned. If you guys have questions, comments, please leave them down below. And that's that. I'm shutting this baby down. So see you later.